Say you find out that a factory is being built by a river and you want to find out whether this factory is going to pollute the river. So you go out and you count the fish, and a year later you count again, there's less fish than there were before. You now have grounds to say that this factory is polluting the river. You could even actively say that this factory is killing fish. However, it's inconceivable that you'd go out and you'd count every single fish in a river. For a start, fish move and you might miscalculate, but also if there's a lot of fish, you just won't have the time to be able to count every single one of them. Therefore, scientists rely on sampling, a way of calculating the size of a population without counting every member of that population. Say, for example, you want to know how many people are living on your street. Perhaps you think, well, there's 5 people living in my house and there's 20 houses on the street, therefore there'd be 100 people living on my street. However, in this case, your sample size is 1 house out of 20. It might be the case that you live next door to a couple who don't have children. On the other side, there might be a little old lady who lives by herself. That means there's 8 people living in those 3 houses, and that you could calculate that there are 53 people living in the 20 houses in your street. That gives you a range of between 53 and 100 people living in a street. 47 people may have just winked out of existence based on your sampling error. Therefore, whenever we take samples, we are always juggling 2 things: time and accuracy. A smaller sample will take less time to count, but will be less accurate, whereas a larger sample will give you more accuracy, but will also take more time to conduct. Therefore, you must always be aware that the size of your sample will affect the accuracy of your results. If you're a biologist going into a field to find out exactly how many organisms might be in that field, you might use a quadrat. A quadrat is simply a square measuring 1 meter by 1 meter, giving you a meter squared area. Biologists will throw these down on the floor and count the number of organisms inside the square. And therefore you can calculate an estimate of how many of that organism you think are in the field, whether that's mice or nettles or tigers. Another thing to remember is that you can't have all of your samples in one place. If you throw your quadrat down and find that there are 3 tigers in a certain area, you can't very well calculate how many tigers there are in the UK if all of those quadrats fall within a zoo. Therefore, when we sample, we throw our quadrats out randomly. This gives us a random distribution for our samples and makes our results more reliable. Therefore, to sum up, the bigger your sample, the more accurate your estimate for your total population, but the more time it will take to conduct. You will always be balancing time with accuracy. Also, your samples should be randomly distributed to avoid bias and make sure your estimate is more reliable.